Hi everyone, and thanks for the chance to talk about autonomous Southern Ocean observations today. My name's Pier Van Der Merwe. I'm a biogeochemist at IMAS, and today I'm going to talk about an AUV water sampling system that myself and these co-authors have produced. So the water sampling system was made for this Nupuri Muka Explorer class AUV, which is pictured here, and it aligns with multiple SOOS activities, including the Underwater Vehicle Task Team, the Under Ice Capability Working Group, and the Munson and Bellinghausen Sector Working Group. The two water samplers themselves are found underneath this hatch, and this is the intake and exhaust shown here. The intake is positively pressurized and the exhaust has a venturi to generate vacuum, and that draws water through the valve bodies of the water sampler. So this is what the actual water samplers look like. There's two of these in the AUV per deployment, and that gives us a total of 20 150 mil samples. That's a 6,000 meter depth rating. It's fully autonomous sampling, which you can base that on mission stage, depth, time, or altitude, but that's highly customizable. The system's completely trace metal clean, and it's been used to collect the full suite of trace metals, oxygen isotopes, which gives you the meltwater fraction, macronutrients, POC, DOC, PAM fluorometry, flow cytometry, just for example. And the AUV takes coincident CTD, dissolved oxygen, and turbidity measurements to complement the dataset. So the science applications, we primarily wanted to answer this question: how will increasing mass loss from the Antarctic continent and iron fertilization that's associated with that into the Southern Ocean feed back into the climate system via the biological pump of carbon, and what impact might that have for the ecosystems? So the system was deployed in the 2019-20 season near the Thwaites Glacier, and the images in the background are showing the area where we deployed for one of our largest incursions, and that was together with our colleagues from COPRI. The sea ice limited our incursion length, but the system performed well, although we have now fine-tuned it based on lessons learned, and a paper from this work is well underway. Preparations are underway with COPRI to deploy again in the upcoming season, with a focus on long under Thwaites ice shelf missions, and that's sea ice dependent. But I show this images in the background just to show how small we are in a very large environment, and to reiterate that systems like this AUV water sampler can be used to overcome some of the challenges. So with that said, thank you very much to SOOS for bringing together engineers and scientists into the task teams and working groups to aid collaboration in future technologies such as this. If you'd like to know more or to work with us with this technology, please get in touch.